Hi all, welcome to Sidza.com. Now we will learn about the classification of solids. Solids can be classified based on the arrangement of the constituent particles into two main categories, amorphous solids and the crystalline solids. So this is the classification in which solids are categorized into two groups, crystalline and amorphous, and this is the classification which is based on the arrangement of the particles, how the constituent particles of a solid are arranged. Based on that, we have two types of solids, crystalline solids and amorphous solids. A crystalline solid is the one where you find some regularity, some particular sequence in which the atoms are arranged. While as in amorphous solids, there is complete disorder in the arrangement of the particles. So you can see here a crystalline solid is a substance whose constituent particles possess a regular ordered arrangement, right? But in case of amorphous, we do not see any kind of regular ordered arrangement of the constituent particles. Let's have a look at this example. Here in this case, you find the atoms not any particular sequence there, so therefore it is an amorphous solid. Here in this case, you find the atoms are arranged in a particular sequence, a regular ordered arrangement is there, so therefore this is a crystalline solid. Another example here, again you see not a particular sequence of atoms here in this case, so therefore this is an amorphous solid, whereas this one is a crystalline solid. Crystalline solids have a definite melting point. They have a sharp melting point, or you can say they have a definite melting point, while the amorphous solids do not have a sharp melting point or a definite melting point. If suppose you have a crystalline solid here, if this is the solid and when you heat it, for a crystalline solid, what kind of observation we can have? If this one is a crystalline solid, then you will see that the whole crystal will melt at one temperature. Okay, it will melt abruptly, so it has a sharp melting point. But if the solid here is a this is an amorphous, right? If it is an amorphous, then you will see the solid starts melting at one temperature and it completely melts at another temperature, right? Means it has a melting point range. Suppose here, just an example, if the substance starts melting at 106 degrees Celsius, right? And some of the substance here melts at 106 degrees Celsius, and the whole crystal melts completely at 109 degrees Celsius, or it completely melts at 110. Now this is an amorphous solid. This is a test also to identify whether a particular solid is amorphous or a crystalline. In case of crystalline solids, they melt abruptly. The whole crystal melts at one temperature. While as in case of amorphous solids, you find a melting point range. Crystalline solids are anisotropic, whereas amorphous solids are isotropic. Means if you have an amorphous solid, it has the same physical properties in all the directions. Isotropic means if the physical properties are same in all the directions, it is amorphous solid. Anisotropy means when the physical properties are different in the different directions. So for crystalline solids, we find the physical properties of a crystalline solid, they are different in the different directions. But for an amorphous solid, if you have an amorphous solid, its physical properties will be same in all the directions. Like suppose we can talk about the refractive index. Suppose if this is a glass, and we know the glass is an amorphous solid. Okay, the refractive index of this glass along this direction, or along this direction, or along this direction, it will be same in all the directions. So the refractive index of the glass is same in all the directions. So this is isotropic. right? Okay, this is isotropic. But for the crystalline solids, it is different in the different directions, right? The physical property will be different in the different directions. You can see here the anisotropic nature of the crystalline solid can be explained with this diagram. You can see, suppose here in a crystalline solid we know that there is a regular order arrangement, and if this is a crystalline solid which consists of two types of atoms, right, you can see here, and there's a particular pattern, a regular ordered arrangement here. But suppose when a ray of light moves from A to B in this direction, and when the same ray of light travels from C to D, the arrangement of atoms here and here is totally different. Or even, suppose if it moves from this direction to this direction, suppose if it is moves from X to Y. So what you find, from different directions the ray of light will encounter with different types of atoms, different sequence of atoms. So therefore it has different physical properties. So that's why crystalline solids are anisotropic, while as amorphous solids are isotropic. Crystalline solids are regarded as the true solids, while as amorphous solids are regarded as pseudosolids or supercooled liquids. The reason why: glass, as I said, is an amorphous solid, and if you take a very old glass pane, right, you will see that the glass, a very old glass pane, is more thick at the bottom, right? At the bottom it will be more thick than at the top. You can see the thickness at the bottom will be more than the thickness of the glass at the top. The reason, because glass, which is an amorphous solid, has some fluidity. The particles, they flow slowly under the gravity, just like the liquids. Okay, but the rate is very, very slow. It takes a lot of time to observe this flow. So the glass, under the gravitational force, flows down. So that's why it's called as a supercooled liquid, okay, or it's called as a pseudo solid, because we know that a true solid is the one where the condensate particles are fixed. They don't have any kind of a translation motion. They don't have a fluidity, right, like that. So that's why amorphous solids are called as supercooled liquids, or they are called as pseudo solids, while as crystalline solids are true solids, because you will not see any kind of this change there in a crystalline solid. Here are certain examples of the crystalline solids and the amorphous solids. Amorphous, you can see the glass, plastic, rubber, coal, and the coke. And crystalline solids, mostly the ionic compounds like copper sulfate, nickel sulfate, NaCl, sugar, diamond, and the graphite. So these are what? These are the crystalline solids. Hope you got the concept. Thanks for watching the video. Bye for now.